We are going to talk about convergent boundary areas. These are areas between plates where plates come towards one another. And we're going to talk about different features and geologic events that occur at these type of convergent boundary areas. First up, just a quick review. What moves any of the world's plates and powers them? The thing that Alfred Wegener was kind of unaware of when he came up with that continental drift theory is convection currents. Remember, this is the circulation of material in that asthenosphere due to heat in the inner and outer core, circulating through that kind of plastic, flexible, silly putty-like material, and the hot material being lower density, it rises up, interacts with the plate. Being farther away from the core, though, it loses its heat and will contract and then sink back down to be reheated again, just like material in a lava lamp. But as simple as that sounds, this happens on a very, very large scale all around the world underneath the lithospheric plates, and scientists believe that this causes all those plates to move and interact with one another in different ways, and has for some time here on planet Earth. So, how do we know about different plate boundaries? A lot of that comes from seismic activity or earthquake events. Another kind of war connection here. I know last time we talked a little bit about World War II and some of the accidental discoveries and technology that was created that ended up benefiting the plate tectonics theory. This is another one. So during the Cold War between the Soviet Union and the United States, after World War II, up until the early 80s, there was a lot of, kind of back and forth, spying and nuclear weapons programs and things like that. And one of the things that scientists did to monitor kind of that nuclear bomb program was they installed seismograph stations around the world that would basically always keep an ear to the ground and look for seismic waves, which are basically waves of energy traveling through Earth's crust. And once again, it had the accidental benefit of being able to detect earthquakes both large and small. And what that did is it kind of outlined for us where these earthquakes were happening, helped outline where these different plate boundaries were located. There are plates all over the world, and some are bigger, some are smaller, but when and where they interact with one another, that is where we get this kind of interesting variety of geologic features and also geologic events, things like volcanic eruptions and earthquake events. So we're talking mostly about the type of plate boundary where plates are coming towards one another and then interacting depending on what type of plates are involved. So one example in the United States where this happens, not too far away from where we are in central Wisconsin, is the Juan de Fuca plate and the North American plate. And if you travel west for a good many hours, either by plane or by car, you can get over to Washington State or Oregon State, and you could be right kind of where the action's happening between that Juan de Fuca plate and the North American plate. Lots of events there. You have volcanoes that have been made, you have the Cascade Mountain Range, and you have sometimes earthquake events in that region as well, all because of those plates moving and interacting with one another. So one thing that's different about convergent plate boundaries is the fact that it depends on what type of plates are involved, and that determines the final outcome, like what's going to happen when those plates come together. So the first type or variety that we're going to look at is when continental plate meets another continental plate. So these are plates that have, for the most part, land masses on top of them. Some plates only have land masses on top of them. Some plates only have oceans on top of them. Some plates are a little bit of both, so it kind of depends on what part or what side of the plate is the one doing the interacting. So in this case, a continental plate converging, coming together with another continental plate. Well, both of those plates are roughly the same low density, and they're also very, very thick. And because of that, neither plate really will overlap the other, a process we call subduction. So what happens here is basically it's kind of like a bulldozer. You have one plate crashing into another plate, and the end result here is very tall mountains. In fact, some of the tallest mountain peaks in the entire world, the Himalayan mountains, are made by a continental plate crashing into another continental plate. During the course of those plates crashing into one another, rocks can get broken and large amounts of energy can be released, so earthquake events can be triggered as well, because that's really all an earthquake is the breaking of rock underground and large amounts of energy being released and then traveling as seismic waves throughout the Earth's crust. So that is an example of what can happen if you have a continental plate meeting another continental plate. You can also generate metamorphic rocks. Remember, those require large amounts of heat and pressure to form, to change certain other rocks into metamorphic rocks through the application of that heat and pressure. And that also happens fairly frequently at convergent boundaries where you have continental plate meeting another continental plate. The next type of plate boundary that we'll look at is when a continental plate meets an oceanic plate. So in this instance, you have an oceanic plate which happens to be thinner and also more dense. So it kind of rides a little lower in the asthenosphere, kind of like a heavy boat versus a lighter boat in the water. The heavier boat is going to sit lower. Because of that, when a continental plate and an oceanic plate come together, the oceanic plate actually gets pushed down or slips underneath the continental plate through a process we call subduction. And when that happens, you get kind of a certain group of things that occur as a result of that subduction. You get a subduction zone, obviously, where one plate is being pushed under another. I'll show you a picture here. You get also an underwater trench. So here would be an example of what I'm talking about. A continental plate pushing against an oceanic plate. You have this deep underwater trench where subduction is occurring. Because you have a plate subducting, it's dipping down into this asthenosphere, and the rocky crust material is basically getting melted off of it, and it will travel through that continental crust, creating a chamber of magma, and that's basically the main ingredient for any type of volcano. So once that magma pushes its way to the surface, you will have some active volcanoes every time these plates interact with one another that are right along the coastline between the continental plate and the oceanic plate. And once again, anytime plates move and interact with one another, you have a high likelihood that rock will get broken, and that energy that's kind of pent up in contorting that rock will get released and turned into an earthquake or seismic event. So this is actually what's happening over in that example I gave before in the Cascade Mountain Range over in Washington State and Oregon, in the northwest corner of the United States. So you have mountains there, obviously. Within those mountains, you do have some volcanoes that will, be active at certain times when the plate movement is occurring. And then also you get seismic activity or earthquake events in those areas as well. And that's because the continental plate and the oceanic plate interact a little bit differently than other plate groupings, because subduction occurs anytime you have at least one oceanic plate. The third type of convergent plate boundary that I'm going to go over with you today is when one oceanic plate meets another oceanic plate. Now remember before when I said oceanic plates are thinner and they're also more dense, so they ride lower on the asthenosphere. And you might be kind of making a prediction here that if two oceanic plates meet together, just like when two continental plates meet together, maybe the same thing happens. But in fact, it's a little bit different. Generally speaking, you're not normally going to have two perfectly identical in density and structure oceanic plates. There's always going to be one that's just, even if it's just slightly older or a little bit more dense, made of more of that basaltic magma and lava, it's going to ride a little bit lower, and that is going to be the one that subducts. So as long as you have at least one oceanic plate, in this case we have two oceanic plates, one of them is always going to subduct. And again, when you have subduction, you kind of get that group of things that occurs. You have that subduction zone, you have that underwater trench, you get earthquakes again, just because you're moving large amounts of rock and releasing energy. But in this case, because you have two oceanic plates and all that's really around is those oceanic plates and then a bunch of water above them, you get, instead of volcanoes on land, you get volcanic islands. So they start out as underwater volcanoes, and given enough time and activity, they will turn into the volcanic islands, very much like the islands off the southwest coast of Alaska called the Aleutian Islands. So that's a case where you have an oceanic plate and another oceanic plate, just like in the picture here. And then over time, that due to subduction, that crust material will be melted off the top of the plate as it subducts down into the asthenosphere, creating that pool of magma and then causing a volcano to form. And like I said, it starts out just a very small volcano, but as it erupts and adds more material to it, and that magma chamber continues to push upwards, eventually the peak or top of that volcano will pierce the surface of the ocean, creating an island. And every time it erupts, it adds a little bit more material to it, thereby adding to the size of that island. So those are all the different things that can happen when plates come together or converge, and it really comes down to what type of plates are interacting with one another. Are they continental? Are they oceanic? Or are they one of each?